Welcome to Catalyst and CMF's renewed culture of innovation, Makers on Screen. I'm your host, Doug Webster, and today's show is Makerspace Startup, Integrated Prototyping. The emerging maker movement has inspired many to pursue design, development, and production of new products that are exciting, utilize new open source technologies, and help make our world a better place. With the opening of new makerspaces in Burlington and many cities throughout the country, where a cross-section of tools and talent reside, prototyping in one space with multiple tools is becoming more and more doable. My guests today, who know all about prototyping, are Matt Flego, Membership Coordinator at the Burlington Generator Makerspace, and Erik Cooper, co-founder with Matt of Matt and Erik Design. Welcome to the show, Matt and Erik.
Thanks, Doug.
Thanks
Welcome.
for having us.
Well, can you tell us about prototyping in the context of making?
It's kind of like, all right, so almost all making in its essence is figuring out a problem.
Mm-hmm.
And prototyping is really unavoidable in a lot of ways. But as far as what a prototype is, I would say it's a step in an evolution towards a solution to the problem.
Okay. Have anything to add?
Well, people will come to us with ideas, for instance, or something that they want to design, or they may even have a patent on, and in order to help realize some of the issues with their designs and the problems they may have, the prototype offers the first step in reaching some of those solutions.
Okay.
Yeah.
Now, can you give us some examples? I know we have some things here on the table here.
Yep. So I'll give a really quick example of sort of a situational answer to this question. My girlfriend right now does needle felting, and it just sort of dawned upon her that it was a really difficult task and was very repetitive. And so we were both searching for new ways to sort of automate the process or make it go faster so that, you know, she could make some income off of this hobby. And at the same exact moment, we were both like, oh yeah, it needs to be like a tattoo gun. And then we started going through the process of making something that looked like a tattoo gun, which is our first prototype, which looked like this.
Oh, neat.
Rather dangerous looking object. It's definitely not refined in any way, but it's a sort of step towards something that will be a tool for her to use and to make a livelihood.
Right, and it allows you to test out the motion, test out how it works.
Totally.
And the next step would be to go into making it look like a sellable object, you know.
Now, what is the material that you're using there?
This is a piece of a 2x4, a threaded rod from Home Depot, bicycle chain link, a pen. No, it's not a pen. It's a mechanical pencil and part of a pen, and some nuts and bolts and welded components.
So you bring together what you can to make it work.
Pieces of garbage.
Low cost. Keep the cost down. Okay. Can you give us some more examples here?
Sure.
Of what you make?
These are sort of higher level examples of things that Erik and I have designed, and we've utilized a few tools at the generator where we have a studio space. And sort of going from right to left here, this would be a corner bracket that goes inside of a case, which holds a TV monitor, sort of like allows a TV monitor to be held in place with a bezel inside a Pelican case for travel and displays, shows, and things like that.
This guy here was the prototype for an air intake on a Harley Davidson's and a Super E carburetor. So the client had wanted to test airflow and change his design slightly that he already has out. And, you know, the 3D printer allows us to go in and do a design iteration directly from the computer. He can test it out, bolt it on, send back changes, and we can move forward with the final design.
Okay. All right. Now, have any of these gone right, you know, are they in place in production somewhere? Or?
He's probably headed toward production on this. This would be seat out of aluminum,
Yep.
You know, eventually. This piece is currently being used on a walker that you'll see later in the program. So we have the option to both prototype stuff for manufacture, and because these parts that the 3D printer makes are also usable, we can actually put them into the product in some cases and use them, which is very helpful.
Now, how did each of you get started in this field?
Well, I mean, you can go for me back as far as Legos,
Yeah.
but
Legos.
I think I grew up a pretty creative kid, and I had the opportunity to go to college at Pratt Institute in New York City. And when I got there, I was actually going for illustration, but I took a tour and walked through the industrial design program and realized that that was probably really what I should be doing in life, and switched majors and, you know, met Matt there, and sort of here we are, you know.
Yeah, sort of serendipitous. I had the same exact evolution where when I was growing up, my father had a project machine shop, so I grew up around tools and things like that. Very into Legos and constructs and rope swings and street fights and all kinds of crazy stuff. But then also going to visit Pratt for commercial art, or at the time of high school it was commercial art, and I got into their graphics design program, and then immediately switched over to industrial design, realizing that, you know, my passion was really making stuff rather than making digital stuff, making artifact stuff.
Actual artifacts, Actual product, yeah, good. And do you find that helps you when you're actually making things, that helps you in your design strategy?
I think that there's something a lot more satisfying to me about making an object, and I think that it's sort of ever evolving. Like now, as we're experienced designers, we're starting to realize that solutions aren't always physical objects, but rather in like a concept. And we just happen to be very, very good at making physical objects because we've been training at it for practically our entire lives.
Right.
But the real sort of best advancements, solutions, are really just good ideas.
Yeah, and industrial design is sort of a multi-step process, and that's what you're seeing here. You're seeing someone will come to us with an idea, and then we're able to take all this knowledge that we've gained over the years and apply it to their actual device or their object or whatever the problem they want to solve is. And the Makerspace is helping us facilitate that with tools that we couldn't probably otherwise afford right now as a small business. So, you know, it's
Right.
And then also access to the community where ideas sort of happen in a very collaborative way.
Yeah. So are you referring to the broader maker movement and the Makerspace, the Burlington generator?
I think it does it for both. I think in most situations, whether it's the Burlington Makerspace or one in San Francisco or New York, the same opportunity is presenting itself for people like us. And then we also can teach younger people some of these techniques and things that we're doing.
Yeah.
So.
We know folks in Brooklyn, New York, who are involved in makerspaces. The generator is linked into other makerspaces in Burlington and New Hampshire even, and you know, the state of Vermont is sort of, well, you know, budding a lot of makerspaces.
Yeah. Yeah.
So I think that, we're really tapped into the culture rather than just that one specific spot.
Right. Good. Kind of like a crowdsourcing type of
In a way,
environment. Yeah.
We met. We had a client at the generator recently to visit us about a prototype that he is interested in that'll help him in the construction industry. And Pete Talbot, our generator in residence, jumped right in.
Yep.
And, really the collaborative effort there turned out with the best idea that we could have come up with. And it was a really great experience for me, and also just sort of for us as a company, and probably for him as well.
Yeah, there's sort of a cross-pollination happening with multiple people within the Makerspace just in Burlington, and then Makerspace to Makerspace, people come together. You kind of feel like you have something in common with other people.
Good. Yeah, we hope to continue to build that. So right now we've got some slides to show you. If Jim and Colin, you want to bring those up? I think about 13 slides here. So if you want to run through this once it comes up, there you go.
All right, this is we had a client come to us who has a problem with her lower back and needed to, had a patent on a device, basically a folding and a walker that it expanded in and out to make the track over the wheels more narrow when it needed to be. And she came to us with a couple prototypes that had already been made, but didn't really solve all the problems. They had issues, so we did another stage of prototyping, and this is the final result that you see here. And it starts out basically with drawing. With
all right, go ahead, roll the next slide. There you go.
Then, basically draw out some of the problems, some of the issues with the device, or some of the things that she wanted to see in the final, and then we were able to go on to the next step. So basically industrial design, it's drawing and then into prototyping.
So next slide, if you can bring it up. There you go.
So here you can see some of the mechanical issues that we were dealing with and working on, drawing ideas out, running ideas past the client to see, what they had.
Next slide.
Here's the hand grip. There was some adjustability in the arms for her that she wanted, and so through drawing and talking to the client, we came up with the best solution.
All right.
And this was a solid 3D model of it made in SolidWorks on the computer, and so this is prior to getting into the final model. So we would deal with the client, talk to him, and say, okay, yeah, we're happy. We'll move forward with the solid model, and then we go into making the parts next, obviously. And then the final device had the ability to fold and shrink and grow, and it had to fit in the car. So there was a lot of issues to solve with a project like this, and that's what prototyping can do for you.
Yeah, next. There you go.
Yeah, you can see some of the details here. Some laser cut parts, some machine parts, a lot of TIG welding on this guy.
Yeah, go next. Yeah.
And a lot of bicycle parts were used because they have easily replaceable parts for maintenance and all that kind of stuff. So pretty simple device, but has a number of complexities. Making the parts, some of them are fairly complex, like these. There's a lot of jigging and fixturing to do.
Yeah, we actually sort of pre-generator ended up hiring a very well-known welder friend of ours, Frank the welder, to
fellow Vermonter.
Yeah, who did most of the welding work on this.
Yeah,
was really, really fantastic. Just did an amazing job on it.
Oh, great.
But yeah,
there's a finish.
Sort of like as we're going through this, this was one of the more interesting jobs that we've done together. Mostly because it was so complicated.
Mm-hmm.
There's so many facets to it, and the client had a lot of needs.
Mm-hmm.
And we ended up running through a lot of iterations. I mean, like that final prototype had been modified several times afterwards.
Yeah.
And probably won't be the end.
Yeah, she wants to get into even going further with it. Maybe
Yeah.
now making it more manufacturable. So that would be the next step to design. Is
Yeah.
basically a fifth stage prototype.
Yeah, I know. Well, hopefully we'll get to a production ready at some point. But one of the last things that we did for her was actually to use the 3D printer to give her some wheel hubs and really strengthen the wheels.
Right, and actual skateboard bearings pressed into here. So we designed the part to accept the bearing.
So this is
3D printed it, pop them in, and then we put it in the wheel, and it actually is a
Yeah.
functioning piece on the walker now.
Yeah.
Cool. Well, you do most of this in Makerspace, in Burlington Makerspace, or you do it in different places?
We have a shop down south in southern Vermont, southern Vermont near
Yeah.
Brattleboro.
I have a farm there, so yeah, I have a garage shop there with simple stuff, but also depending on the capabilities of the machines of the generator, we do sometimes send stuff out.
Yeah.
But one of the things that the generator has really helped with is that now we don't, and time is money, and we can make iterations faster. So now we're subbing out parts a lot less.
Well, can you tell us a little bit more about the generator itself? What type of equipment does it have? What's the arrangement for membership and all that?
The deal for us, which is a little bit different than some people at the Makerspace, is that we have, the first thing is that members are charged a certain amount, and if you volunteer, you can bring that amount down to, I believe it's as low as $15 now.
$15 a month.
Yeah.
Yeah.
And then you get access to the space and the tools.
Yeah.
And there are classes that involve certifications, and that certification process is something that is developing into something that might be a little bit more universal in the future, where you could take it to another makerspace. But for now, it's specific to the generator. You can also rent cubicles there. They're like $125 a month, or I might be speaking out of turn. I don't know. I don't know the exact prices. But we have sort of taken 2 cubicles, which is a little unusual. Sort of like embedded ourselves in the makerspace as a business, and I'm hoping that it doesn't necessarily change so much. The idea of an accelerator is that, or a makerspace in this particular instance, is that comes a point where you'll get kicked out, or you get too big.
Right.
And we feed.
Which is a good thing.
Right.
Yeah, I mean, it's definitely a good thing. But we
It's a
have
good problem to have.
we have like a lot of parallel with the space,
Yeah.
where there's a lot of mutual benefit,
Right.
for us being there and being senior designers and makers and giving knowledge away to the rest of the crowd.
Now, what would you have done before Generator? If you were to do the same types of projects, what would you do?
We had a number of
would it be doable?
Yeah, we had a number of services that were out of state, or people in New York or Boston that have the machinery to do it, but they charge a fair amount of money. There's shipping time involved.
Yeah.
So this has really helped us streamline, because tool-wise at the Generator, we have a 3D printer, there's a laser cutter, vinyl cutter, there's a metal shop, there's sandblaster, there's a wide, there's a plethora of tools. There's now a wood shop going in, which is great. So those tools allow us to streamline the process a bit for what we do, which is really helpful.
Yeah.
And then there's always carving stuff out by hand,
Right.
which is a lot of fun.
Yeah.
Yeah, we used to whittle and
Yeah.
chisel away at stuff and sand foam, and it was a lot more handwork.
Very cool. So when it comes to your business together, Matt and Erik Design, who are your customers? Are they entrepreneurs? Are they companies? And then are you looking to do your own business in terms of production business?
I
or
think
manufacturing?
all of the above.
Yeah, we've had people from people who just have blue sky ideas and a whiteboard drawing, to people who actually have a patent, who haven't prototyped to the point where something's really worked out yet, and they want to come and we'll go through our process with them to develop it. And then we're also developing a line of furniture right now of our own. For that, we've developed a small CNC machine that Matt made at the Generator.
Right. In fact, we have some slides on that. Jim, you want to show us the next set of slides? And then a short video too.
Yeah.
Bring it up.
Yeah, and it's it's something that helps us keep manufacturing in-house, and make our process a little easier.
Now what are those there?
Oh, some of our tools.
Okay.
Lots of marker drawings going on in our office, so that's generally where a lot of stuff starts, is right on paper.
Okay.
And then this is the CNC machine. Matt could probably tell you some more about that.
Yeah.
So it started out as a small open source kit that I got from this company called Inventables. And then slowly sort of evolved into a much more rigid and industrial sized machine based on our needs. We kept shooting for this goal to be able to mill a stool top in less than 15 minutes. And we kept modifying the machine, making it stronger, faster, better cutting, all the way up until we finally reached our goal, which happened, you know, probably 2 months ago.
2 months ago.
Took about a year and a half.
So yeah, go on to the next slide. I think we have a shot of those.
Oh yeah, so these are the bar stools. The top is made on that machine that we built ourselves, and then I build the bases by hand with the tools metalworking tools that I have in southern Vermont.
Oh, nice.
So
It's a cafe in southern Vermont.
yeah.
Yeah.
Oh, nice. And they're actually they're out there.
Oh, yeah.
You sold these, and you're
Yeah, we
off
have a
and running with
client
that.
in Montpelier that's going to
Yeah.
have some soon, and
Yeah, great.
they're commercially available.
Great. You want to show the video on the CNC carver?
And in
Look at
the video, you'll see several parts that were 3D printed at the generator. Not to plug the generator too much, but if we didn't have this machine, I don't think the other machine that I made here would have been possible.
So yeah, there's that drive wheel is printed, right?
I do have a drive wheel here. That one was purchased.
Where the hose plugs in is 3D printed as
Yeah.
well to adapt to the machine.
There's also that lead screw on the Z-axis is 3D printed.
It should be this guy here.
Yeah, which is this part right here.
Okay.
And you can see on the table there are like several iterations. This one broke. It originally looked like this, and then it morphed into this, and finally to that part you see in the video.
And then also these clip the belts down.
Yep.
So you make mistakes all the way through it, right? Or you have failures all the way through it,
Right.
right?
Yeah.
And is that part of the? I mean, that's part of.
Yeah, that's the
doing
learning
something,
curve,
isn't it?
the vertical learning curve in this
Yeah.
stuff. But what the 3D printer allows is to have a part fail, and then we know to change the engineering on it a little bit, and
Right.
can make another one in 2 hours and be back on track.
So it's pretty difficult to design something without actually making it, I would assume.
You got to have years of knowledge if you want to be that guy. You know,
Yeah.
those are it's a learning process for us as well.
I would say that the idea of prototyping is kind of like intentionally failing
Yeah.
multiple times
Multiple times.
until you finally get some, well, not just something right, but multiple things right.
Yeah. Now you mentioned, I know you use "guy" as a general term there, but as far as women, do you see more and more women getting into this?
I see a lot more women interested in it, and a lot more women sort of making a discovery about getting into this kind of a field.
Yeah.
I would say it's definitely a male-dominated field. As far as making is concerned,
What about as far as making? Yeah. Prototyping male generally, but as far as making, you get
it's all
more.
over the place
Yeah.
now. You know, I mean, it's becoming pretty diverse,
more.
I'd say.
Yeah.
And what's really great about it is that the younger generations are getting involved at, far sooner than we were,
Yeah.
which is a great
Right.
thing now, because it's getting them up to speed with what's going on in the world, and ultimately this will keep growing and moving forward, undoubtedly.
Well, now, how do you inspire that younger generation? I mean, what would you recommend? Like teachers, should they get into this? We talked a little bit about that earlier.
Oh yeah, I mean,
We-
why not have a 3D printer in every classroom? In my opinion,
Yeah.
I mean, it's
Yeah.
I mean, back in the day, we used to have shop, right?
Right.
shop
Right.
class.
And
yeah.
then there was a brief period after shop class where liability became a thing. And now the tools have changed and sort of either gone around the liability or sort of become more accessible in a way. And I think they're starting to come back into the classroom. But if I had to sort of like say one thing to teachers in a younger generation, it's just develop X-ray vision. Like try and take things apart as part of your
Right.
curriculum, or even though your parents say, "Don't do that," do it.
Well, also, I think with what's going on with 3D printers and the maker movement now, it's also important to realize that a lot of these high-tech tools can be used to solve
Yeah.
big problems in the world. Not just,
Yeah.
a refrigerator magnet or whatever. We can do amazing things, medical devices and high-tech things that could really help people
Yeah.
and change the way things work nowadays. So I think that's a big, component of it.
So it's in what you're saying. Do it. Jump right into it.
Yeah,
Jump
like
right into it.
like
Don't be
there's
afraid
too
of
much.
it. Go forward.
There's definitely a lot of hesitation.
Yeah. Yeah.
Like discovery is all about making leaps that are just risk,
Yeah.
really, in the end. And I feel like the climate today is very risk averse, and it should be more risky.
Yeah.
Well, the Makerspace allows you to play a bit too,
Yeah,
which is
exactly.
come and learn the machine and be able to make a piece and see how it goes and make changes, and that's it's a big deal.
Now, if somebody had an idea, what would you recommend to them? We got about 20 seconds. What would you recommend them?
If someone had an idea, just start iterating as much as you can, like explore all the options.
Get it on paper quick, so it's
Yeah.
your idea.
Yeah, and
Ideas go quick now.
and get it
Yeah.
out get it out
Right.
into the
Go
open
quick.
as much as you can.
Out into the open. Don't hide it.
Don't
just
hide
get
it.
out there.
Yeah,
And
don't protect it as much as you would like to because you're scared of
Right.
what's going to happen to you as a consequence.
Right.
Getting ripped
Right.
off. Get ripped off.
Okay.
Like go put it out there as much as you can.
all right. Well, that's about all the time we have here. Thank you for being on the show, Matt and Erik. We
Thank
appreciate
you.
coming out.
Thanks for having us.
Okay. Today's show was on Makerspace Startup, Integrated Prototyping. For more information about this show, related internet links, and other shows in this series, go to retn.org and look for Makers. Also, for more information on integrated prototyping or prototyping, visit Matt and Erik at mattanderikdesign.com. Thanks for joining us.